for questions like work example 5 on page 138, often these need a couple of steps to happen. So first of all, you want to simplify the given function. So that'll be our first step. So let's go ahead and do this just by simply multiplying out our brackets here. So I'll end up with, equals, and that'll be e to the 2x. So remember, it's x plus x. That gives me 2x. And then it'll be minus 2 times e to the x. Once you have your equation like this, now you can go ahead and differentiate, and you just differentiate this term and then you differentiate that term. It's just one term after the other. So simplify first and then just go ahead and differentiate. So we'll go ahead and do that now. So my f dash of x is going to equal. So remembering what I've been doing previously, I have been differentiating this value up here by letting this equal u. Okay, so I might just pop that over here. So if I have e to the 2x, let's make that e to the u. So we're saying u equals 2x. Okay, so when we go ahead and do this, we can find dy du. So when I differentiate this term, remember, you just still get the same thing, e to the u. And you have to differentiate that what's in the index, that 2x, and you get du dx, whoops, not dy, du dx will equal 2. Now, if you can see a pattern here, notice that when I then put this answer together, my dy dx, just for this little bit, is going to be dy du, that's that e to the u, that 2 is there, and then remember I rearrange them, so I go 2e to that and I replace that u with what it was, okay? So there's actually a way we can do this just by inspection, so I'll try and point that out to you now. So our derivative of any exponent, okay, the exponent is going to be in our answer. So if we start with y equals e to the 2x, that e to the 2x is going to be in our answer. And then what goes in front of it is the power, this bit up here, just what is the differentiation of that. So the differentiation of that, 2x, is just 2, and that 2 comes down the front. So actually you can just look at this expression and go, okay, well the derivative will be, well what's the derivative of that? 2, that's going to come down the front, and then it's just e to the 2x. So I can just here use that same thinking here. Differentiate the power, that's 2, that goes out the front, and then it's going to be times the exponent with the original power, e to the 2x. If you can't see that pattern just by looking at it, you can go ahead and do the pattern that we were using just before in the chain rule. And then I'm going to take away, and then that's just going to stay as 2, because the derivative of e to the x is just e to the x, so it's 2e to the x. So here now I've got a common factor. I've got e to the x that I can take out of each term. So I'm going to take out, oh, and a 2. So we've got a 2 in both terms. So let's take out 2e to the x as our common factor. And then I would have one lot of e to the x left in that first term. And over here, I'm just going to have 1 because I've taken out the whole thing, 2e to the x, 2e to the x. So it'll just be e to the x minus 1. So there's our derivative for that one. So then when we go ahead to number 2, they build in this extra step. Again, we want to go back and we want to simplify first. And this is where you need to have some fraction memory. So if I've got something minus something all over a denominator, I can split that denominator apart. So it'll be e to the 2x over e to the x minus 2e to the negative x over e to the x. Now when I am dividing, what happens to my indices? They subtract. So this is going to be e to the 2x minus x minus 2e to the negative x minus x. Okay, so when I am dividing, then I am subtracting my indices. So then when I tidy this up, 2x minus x is just x, so that's e to the x. And what have I got over here? That 2 will stay there. Negative x minus another x, so I end up with e to the negative 2x. Okay, so we've ended up with e to the x minus 2e to the negative 2x. So that's just the simplification part, okay? Let me put my draw tool back on. So I have simplified my f of x. So now I need to go ahead and differentiate it. And I, again, can just do each term. So I'm going to do that. So f dash of x will equal, well, e to the x differentiated is just e to the x. It stays the same. That's one of the easy ones. And then when I differentiate this one, it's going to be minus 2. And then I look at the function index here. It's negative 2x. Differentiation of negative 2 is negative 2. So that negative 2 will come out the front. And then it will be e to the negative 2x. And now I just need to tidy all of that up. So it's e to the x. Minus 2 times minus 2 becomes positive 4. And then I have e to the negative 2x. Just be aware that if you have a negative index, your book may always give answers with a positive index. So remember, a negative index, that indicates a fraction. Okay, so equals a fraction. So remember, you can go ahead and rewrite this as e to the x plus 4 over e to the positive 2x, just shifting that whole term into the denominator and making the index positive. So that is for worked example 5, and that relates to these questions that I've written up here for you. So head along to some of those and see how you go.